Part 3, Laws of Logarithms. In grade 9 math, the exponent laws were introduced. They are the product law. When multiplying two or more values with the same base, we simply add the exponents. So that was something like x to the 5th times x cubed. Okay, so we have something like that. You add exponents and you get x to the 8th. Nothing new here. Quotient law, when dividing two values with the same base, we subtract the exponents. So x to the 5 over x to the 3. So we just subtract the exponents and we get x squared. Okay, the last one, the power law. When given a power of another power, we multiply the exponents. So that's like x to the 5 cubed. So that is x to the 15. Perfect. Okay, so once you have that, okay, so those are all the exponent laws that you need. Now, as logarithmic functions are inverses of exponential functions, the exponent laws can be inverted to create the laws of logarithms as follows here. So, these formulas are on your formula sheet, and it's just my job to teach you how to use them. Okay, so the product law, so log base b of m times n is equal to log base b of m times log base b of n. So, how this is going to work for us is if we have something like this, log base b of, I don't know, let's go 3x. Okay, so what we can do, the 3 is timesing the x, so I can separate out, okay, so this is like 3 times x, so I can separate this out into log base b of 3 plus log base b of x. Okay, so we can separate the logs going that way. It just makes things easier to solve. Okay, the quotient law says if I have log base b of two things that are dividing, then they subtract. So this would be something like log base b of, I don't know, let's go 21 over, I don't know, let's say y. Why not? Okay, so that's just going, like the 21 over y, that's a dividing thing, so I can just separate the two parts out. So log base b of 21 minus log base b of y. Okay, and I can just do that. Here, what happens if there's a couple of things together? So let's say we have log base, let's go 3x over 2y. Okay, so, and log base b again. So the 3x, those multiply, so that's going to be log base b of 3 plus log base b of x. Now the two y's on the bottom, so we can separate that out into 2 and y, like they can make them completely separate from each other. So I can go minus log base b of 2 minus log base b of y. That's a little bit trickier. Now the reason why they're both subtracted is because they're both on the bottom. Now they are multiplying each other, so I could write it like this. Log base b, of 3 plus log base b of x minus, and then I can put them in brackets and go log base b of 2 plus log base b of y. Now, the reason I would do that is because the 1 subtract has both the 2y on the bottoms. Okay, so they're both being subtracted, but the 2 is multiplying the y, so we could add them. Okay, but if you look, the negative will distribute to both pieces, giving you the negative log base b of 2 and the negative log base b of y. Huh, clear as mud, right? Okay, don't worry, we'll practice these. It won't be a problem. Okay, so the power law. So if I have the log of some kind of argument that is raised to a power, okay, so that says that that exponent can jump down in front. Okay, so let's give some real numbers with this. So if we have log, I don't know, base b again, sure, why not? So x to the 5. Okay, what we can do with these is that exponent can just jump down in front. So that is going to equal 5 log base b of x. Okay, one of the things that comes up a lot in these, log base b, is square roots. Now remember, a square root is just a fractional exponent. So this is really just log base b of x to the half. Okay, and that half can jump down in front. So we can go half log base b of x. So now we can combine all of those. Okay, and then the last log law that you have to know, formula on your sheet, is the change of base logarithm. And all that means is if I have log base b of c, okay, I can go log of the c value, so log c divided by log b. Now when I do that, I can pick any base here for the 2 that I want. Usually we convert that to log base 10 because that's what the older calculators or the older TI-84 operating systems is. It's all log base 10. So you would go log c over log b. So for instance, if I had log base 3 of 81, okay? Now, on most calculators, the TI Inspires and the newer TI-84s, when you type the log button, it gives you that base template, so you can put the 3 in here and then the 81, and it'll solve it. It'll just be 4. Okay, if you don't have one of those calculators, okay, so what you would do is you would just go log 81 divided by log 3. Okay, now this is the change of base formula, so if there's no base there, it's assumed that it's log base 10. Okay, so this is how your calculator kind of got around it if you still have one of those. So log base 10 of 81 divided by log base 10 of 3. Okay, so again, if you don't have that template, it's just log 81 divided by log 3, and your calculator spits out 4. Okay, it's kind of a handy trick that we can all use. Even if you have that template, there's nothing saying that we can't use any base we want. So it doesn't have to be base 10. It could be base 5, base 2, just whatever. All right, so let's have a look at, sorry, I had some writing on here. Okay, so let's have a look at these laws in action, if you will. Okay, so we want to expand each expression. So now there's not a lot of room here, so I'm going to write fairly small. So you know what? I'm even going to do A up here, just because I have room. You have enough room on your sheet to do it right beside. But okay, so if I have log base 4, so look, the x cubed and the y are multiplied, and the 4 and the z, they're multiplying each other, but they're both on the bottom. So when we separate these, we're going to separate them into minus logs each. Okay, so this is going to be log base 4 of x cubed plus log base 4 of y minus log base 4 of 4 minus log base 4 of y. Right? Both the 4 of y, 4 of z, my goodness, guys, I'm so sorry. Okay, both the 4 and the z are on the bottom. Okay, so we separate those out into 2 negative logs each. Okay, now we're not quite done because that 3 follows that third log rule. Okay, so that 3 jumps out in front, so 3 log base 4 of x plus log base 4 of y. Now, remember I told you there was this logarithmic identity? So log base 4 of 4 is just 1 minus log base 4 of z. Okay, so there you have the first one. Now B has that square roots I was telling you about. Now when you have something like this, we need to separate or distribute that square root to all the pieces it belongs to. So before we even start the laws of logs, we're going to use the exponent laws and figure this out. So this is going to be log base 5 of xy cubed, okay, and then square root is just a to the 1/2. So really this is going to be log base 5. Okay, now remember that square root, or that 1/2 exponent, is going to belong to the x and to the y. So that's going to be x to the 1/2, and then y, okay, so y cubed to the 1/2, that's y to the 3/2. So now that I have that, now I can do the laws of logs on it. Okay, so the 1/2 is going to jump down, so we're going to get a 1/2 log base 5 of x plus, okay, and then the 3/2 is going to jump down in front, so 3/2, and then log base 5 of y. Okay, so that's how we separate those logs. See, the root belonged to everything, so we had to combine that with the x, combine that with the exponent that's already on the y before we can separate out the logs. Okay, so if you look at this next one, okay, so there's no actual base here. So if there's no base, we assume that it's log base 10. Okay, so we'll get there in a minute. Okay, so you'll notice there's a root, but the root just belongs to the x. So remember, the index is 3. So this is really just log 100 x to the 4/3. Remember that rule? The index on the root is just the denominator on the exponent's fraction. Okay, so 4/3, and then of course over y squared. Okay, so that's how we set this up. We get rid of that root, turn it into an exponent. So this is going to be log 100 plus, okay, so we separate out the x to the 4/3. So that 4/3 is going to jump down in front of its log. So 4/3 log x. And now the y squared is on the bottom, so it's going to be a subtracting log. Okay, and then that 2 will jump down in front of it. So minus 2 log y. Now remember, these are all base 10s. So base 10, base 10, base 10. Now log base 10 of y, you can't really do anything. Log base 10 of x, you can't do anything with. But what is log base 10 of 100? Now remember, I showed you that little trick, and I'm going to write here, I'll erase it in a second. Okay, so log base 10 of 100. Remember that we put a blank here, and 10 to the what is 100? Well, 10 squared is 100. So log base 10 of 100 is 2. So this is 2 plus 4/3 log x minus 2 log y. And that would be our final answer for that one. Okay? The idea is if they give you numbers, they probably want you to simplify those numbers. Okay, so I'm going to erase this, and then we'll get on to number 2. So rewrite each expression as a simplified single logarithm. Answers should be written with positive exponents. Okay, great. So we're just going to, so basically a positive exponent, so no roots is what the idea is there. Okay, so we're just going to have one big log. Okay, so now look, this guy is positive. So any positive logs go on the top of a fraction. Any negative logs go on the bottom. Okay, so we have log, and this is log, all logs base 2. Okay, and then we're going to have a fraction here. Okay, so this is going to be x cubed on the top. Now look, this 4, he's going to jump up. So we're going to get x to the 4th. Okay, but oh look, it's a negative. So that x to the 4th is going to go on the bottom here. Great. And then, oh, wait a sec, an x to a root x, that's an x to the 1/2. But look, he's a negative log again. So that means he goes on the bottom. So x to the 1/2 on the bottom. So that's great. Now that we have all the logs separated, we have to look at this part to see if we can simplify. And oh, of course we can. Okay, so it's x3, or x cubed on top, x to the 4th. So these are all just subtracting each other. So 3 minus 4 is, so an x on the bottom, or an x to the 1 on the bottom. So this is going to be log base 2, okay, of 1 over, so this is x to the 1 on the bottom times x to the 1/2. So 1 plus 1/2 is just 3/2. So this is going to be log base 2 of 1 over x to the 3/2. Okay, wow, that was intense. Sorry, my 3/2 just got so small there. So 3/2. All right, so that's how you simplify that one. Okay, so 4. Okay, b, pardon me. That 4 is going to jump up onto the y squared. Log base 6 of y, that's got nothing. The 2/3, that's an exponent on this y. So that's going to jump up. So we're going to end up with one big log, so log base 6. Okay, so I'm going to get y squared to the 4th times, because we're adding logs here, so it's times y. And then we divide by, okay, so because it's a subtract log, so y to the 2/3. Okay, so now we do some combining. So y squared to the 4th is y to the 8th, times y is y to the 9th. So this is going to be log base 6 of y to the 9th over y to the 2/3. Okay, and then because the two y's there, we just subtract. So 9 minus 2/3. So that's 8 1/3. And we won't worry about an improper fraction. We'll just go log base 6 to the y to the 8 1/3. I guess technically that's what, 8 times 24, so 25/3 if you really want. So log base 6 of y to the 25/3. Now your calculator will also do that for you. 9 minus 2/3, 25/3, just done. Okay, so then this last one, so we have an adding log. So these two arguments are just going to multiply. So this is going to equal one big log, x minus 3 times x plus 4. Now, this is interesting because we could leave it that way, but I know what's coming. And we're going to have to FOIL this and solve stuff later, so we might as well get used to it. So this is going to be log of x squared plus 4x minus 3x, so it's plus x minus 12. So that's going to be our final answer for this one. Okay, the logs were added, so we just multiply the two arguments. Okay, great. Cooking with gas, woohoo. Okay, number 3, evaluate each expression. Okay, so log 1 minus 10 log 1,000 plus a half log 100 minus log bunch of zeros squared. Whew, okay. Well, tell you what, let's do some converting here. Okay, this guy, log 1. if you just type that in, log 1 is 0. Okay, remember, this is log base 10. Okay, if you just write log, it's base 10. Okay, and then to the 1. So 10 to the what is 1? Well, 10 to the 0 is 1. So this part is just 0 minus. Now, 10 log 1,000. Okay, well, log 1,000, log base 10 of 1,000. Okay, so 10 to the what equals 1,000? Well, that's 10 cubed. So here, minus 10, so this is 10, and then log 1,000 is 3. So we have 10 cubed, which is 1,000 again. What's important about that is 10 to the log base 10. That's another one of those log identities. So 10 to the log base 10, that just cancels, leaving us with 1,000. It's kind of a neat little trick. Okay, so remember here, this a half jumps up. So remember, a half exponent is a square root. So this is log square root of 100. Oh, guys, remember what is the square root of 100? Well, it's just 10. So this is going to be plus log 10. Well, that's interesting, because look at this. It's because there's no base, so it's log base 10 of 10. Well, 10 to the what is 10? Well, that's 1. So that's log base 10 of 10 is just 1. So 0 minus 1,000 plus 1. Okay, now this one's going to be tricky. Okay, so this 2 can jump down in front, so that's going to be minus 2. And then log base 10 of 0.00001. Okay, well, hopefully you know that is 10 to the negative 1, 2, 3, 4, 5. That's kind of a scientific notation thing. Okay, so this is log base 10 of 10 to the negative 5. The log base 10 and 10 cancel each other, so we just get negative 5. Now, if you don't like how I did that, you can just type this in. Log base 10 of 0.0001, and that equals negative 5. So we're going to have negative 2 times negative 5. Remember, that 2 came from jumping down in front, so it's minus 2. Okay, so now we've got a whole bunch of numbers to play with. So negative 1,000 plus 1, okay, minus plus 1, then plus 10. So that's going to be, let's see, so that's plus 11. So negative 1,000 plus 11 is negative 989. Okay, marvelous. So that is that one. I know there was an awful lot of math going on in that particular question. Okay. All right, perfect. Okay, so then this next one, so there's a whole bunch of numbers here. Okay, tell you what, I did a whole bunch of math in A. Let's just let our calculator do a lot of the talking here. Now, the first thing you're going to notice in B is there's a log base 6 and a log base 4. Okay, log base 6s do not play with log base 4s. They're not very nice to each other. They're not like terms, so they don't combine. So, however, we do have another log base 6. So the two log base 6s will go together. So if we just write this out beforehand, so 216 minus log base 6 of the 4th root of 36. Wow. Okay, and so we put the 6's together, then log base 4 of 32 plus log base 4 of 8. Okay, so we put the log base 4's together, the log base 6's together, and we can go from there. Okay, so how this works is if we combine them into one logarithm, So that's log base 6 of 216 divided by, now remember, a fourth root is a to the quarter. So this is going to be a 36 to the 1/4. Okay, not a problem. It's just is what it is. Okay, so and then the logs over here, the log base 4s are adding together. So that's going to be 32 times 8. All right, so that's certainly doable. Now, to finish this off, we're just going to type log base 6 of all of this into our calculators. So log base 6 of 216 over 36 to the 1/4. So when you type that into your calculator, you get 2.5. Okay, and then when you type this guy in, okay, so log base 4 of 32 times 8, okay, that one just works out to positive 4. So 2.5 plus 4 equals 6.5. So that is our final answer there. Okay, number 4. Given that log base 5 of 6 is A, and log base 5 of 7 is B, and log base 5 of 8 is C, rewrite the following logarithm in terms of A, B, and C. So all this means is that we're going to end up factoring all of these things. Okay, so log base 5 of 5, so when we factor 30, we want to have 30 in terms of 6, 7, or 8. Well, 7 is not a factor of 30, neither is 8, but 6 is. So we're going to write this as log base 5 of, okay, so 30 is 6 times 5. Okay, and then 56, we want to have either factors of 7 or factors of 8, and what you notice is that 56 is 7 times 8, so that's nice. Okay, so now what we can do is we can separate all of these factors. So this is going to be log base 5 of 6 plus log base 5 of 5, which is just 1, remember, okay, minus log base 5 of 7 minus log base 5 of 8. So we factor, and the question gave us hints as to what we want to factor, because we're not going to factor 30 into 3 and 10, because 3s and 10s had nothing to do with the question. Okay, so we want 6s, 7s, and 8s. Okay, so then we have, so log base 5 of 6, that was A. So that's A. Okay, plus log base 5 of 5, that's just 1. So A plus 1. Then log base 5 of 7 was B, so minus B. And log base 5 of 8 was C, so minus C. So there is the expression written in terms of A, B, and C. Wow, kind of tricky and complex, but not terrible. Okay, so I want you guys to practice this stuff, and when you're done, show your teacher so that you've actually finished the formative assessment. Remember, the answers are in the back of your textbook, page 400. Do at least this much. The laws of logs are not that hard. It's just you really need to practice. So again, I'm going to encourage you to print off the pages from the workspace sheet, because then you can write all over them. If you don't want to do that, then just use loose leaf. Either way works just fine. And we'll see you next lesson. Thanks.